Okay, all right. Well, good morning and happy Wednesday. I hope you guys are doing okay. I hope your projects are coming along okay. You guys are meeting with your groups, and again, if you have any questions, I've got lots of office hours, and so don't hesitate to reach out. During the kind of project proposal meetings, a couple groups kind of mentioned, or during our, I guess, the discussions that I had with the with the groups, a couple groups, we agreed that it's probably a good idea that they need to find a little bit of extra data to kind of supplement the current table of data that they have. And there are lots of places where you can try to find data, and it can be kind of tricky. One of the most useful places where you can get data is Wikipedia, and there's lots of tables of data there, and they're all kind of well documented, well cited. And then and this, what I'm going to show you today, doesn't apply just to Wikipedia, but really any kind of site where some data is presented in a table, but not necessarily in a format that can be easily downloaded. So we're going to look at using a couple tools within R, or primarily one tool called RVest. Okay, and RVest is kind of this play on words on, I guess, harvesting, like harvesting data. And so I'm going to go ahead. This file, if you want to follow along, is on Canvas in the it's titled "Scraping Data from the Web.R." It's a little script. You can download that, and in this case, all you need is just need to be connected to the internet. You don't need to download a separate data file. So I'm going to go ahead and load up Tidyverse, and then load library RVest. If you don't have RVest already installed, you can always go to the Packages tab, click Install, type in RVest, R-V-E-S-T, and then install it there. Or you can also do install.packages, RVest, whatever is needed there. Okay, one of the groups wanted to look at the GDP of different nations as kind of to see if there was correlations between a nation's GDP and the variables that they have in their data set. And so I just went to Wikipedia and I typed in GDP, and it says list of countries by GDP nominal. There's a few other, they have several of these lists. There's GDP per capita, and I'm not sure which what's the best way to go about. But let's say you wanted to get the data from Wikipedia here, list of countries by GDP nominal. Okay, if you didn't have RVest, probably what you would end up doing is you would highlight this page, okay, and you'd scroll down, and then you'd hit copy, and then you would come. Oops, see, it's tricky just to even highlight the table, and you would hit copy, and you would go over to Excel, I imagine, and you would paste it in there, and I love Excel, and I think it's great, but I just hit Control V on my keyboard, and it copies it, but Excel is so advanced that it copies all of the formats, all of the little pictures and icons of the flags, which is great on the web page, but we don't actually need, right? So this actually, I'd say all of the advanced features of Excel actually make it a little bit harder. There's a few things you can try, like pasting only the values, but anyway, we're not gonna. What I'm gonna try to show you today is not to avoid that situation where you're gonna be copying and pasting from into Excel and then cleaning it up. And so what I'm gonna do is we're gonna have R visit the web page and download that. Okay, so here I'm going to take the web address, the URL, and I'm going to put it in quotes. All right, and I'm going to just store this as URL. Okay, and then I'm going to use this function called read_HTML and put the URL in there. Okay, and what that's going to do is it's going to read the HTML off of that page. All right, so HTML is the markup language. You can always I don't know if you've ever done this, or maybe you've accidentally hit one of these buttons, and then you suddenly see all of this stuff pop up on the side. This is the kind of the underlying HTML code, and what R is going to do is it's basically going to download and read all of that, and we're going to try to extract the information from there. So I just do read_HTML, and I'm going to store it as page here. Okay. And so you could click page, and it just says doc, and it's got all of this stuff in there. Okay. Arvest is actually, there's like a lot of stuff you can do with it, and you don't have to just extract tables of information. You can extract other bits and pieces of information, and there's quite a few tutorials online. I would say, for now, we're going to just assume our data is in a table, and pretty much all tables in HTML have this like table tag, and so you can just tell R, search for the table tag. Okay, and so to do that, I'm going to take the contents of the page, and from the contents of the page, I'm going to tell R to read anything that has a table tag. And so you say HTML nodes table. Okay, HTML nodes table. All right. And if you do that, so right now I'm not saving this anywhere. I'm just asking R to kind of show me how many nodes have the tag table in it, right? And it comes back and it spits all of this out. And one of the things it says is XML node set 7, and it says and it lists them off, and it's all just a bunch of kind of gibberish code here. But what this is saying is that on this web page, there are 7 tables embedded somewhere in this web page. And so tables not only just contain data, but sometimes they're just used to kind of organize like captions. So the caption on this map of the world has like the different colors shaded and things like that, and that's organized in a table. Also at the very bottom of the Wikipedia page, there's a bunch of like links related to GDP, and that's organized in a table. So anyway, even though when you look at the web page, you only see maybe like one real table or maybe a couple of them, internally there's 7 of these tables. Okay, and it's it's hard to just look at this table and figure out which is the table you want. So what we're going to do is we're going to kind of just select one of them at a time, and then we'll ask R, show me the contents of this table. Okay, so I'm just kind of continuing to pipe all of these operations together. All right, are you guys able to see this okay? All right, so again, I'm taking page, and then we're piping this into HTML nodes table, and then to select just one of those tables, the function we want to use is this double square bracket function. Okay, and that allows us to extract information out of an item in a list. It's a little bit of a funny function because when you normally use the double square bracket function in R, you use it as like in conjunction with a list or a data frame or tibble or something. But here, the format in which I present it is you have to surround it with backticks. So we're going to do, from the page, look at everything that's a table, and then I just write backtick, square bracket, backtick, parentheses, 1. All right, and I know it's funny. Just kind of, I guess, go along with it, and this will work almost universally with any kind of HTML web page that has a table on it. I guess maybe at this point I'll just insert a caveat and say Arvest does not work well if a page has dynamic content. So think of pages that kind of have infinite scroll, where as soon as you, like, if you're going on Facebook and you're scrolling and you reach the bottom of the page, it just automatically loads additional content. Arvest isn't going to work well for that. Arvest also doesn't work well. Well, it's not going to work well for Facebook because you have to like be logged in to even like view that stuff in the first place. So Wikipedia is great. You don't have to log in. There's no infinite scroll. A lot of kind of reference sites is going to work well. But anyway, back to this. We want to just extract out the first table and see what's in there. And so the structure is we start off with the page. We look at everything with a table. We're going to look at the first thing that is called a table. And then we pipe that into this function HTML table, which turns that table into something we can read on R. And so I'm going to just go ahead and run this. And it comes back and it just says this one thing. It says largest economies in the world by GDP nominal in 2023 according to blah, 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 the IMF. And so we go, okay, well, that's not really what I'm looking for. What we're looking for is this big table with the GDP and, you know, the 216 nations listed. That's what we're looking for. So we'll, you know, we tried, we didn't find it. So I'm going to run the exact same code, and I'm going to replace the 1 and replace it with a 2. And we're going to say, let's look for the second table, and let's see what the contents of the second table looks like, okay? All right, and so here, I get just kind of more gibberish, and it, you know, stuff I can't even read this, right? .mw parser output .legend blah blah blah, and it's got a bunch of stuff. So this is not what we're looking for. It'll be clear that you found the right table. So again, I'm just running the exact same code, just changing it from saying look at the first thing, look at the second thing, now we're going to look at the third thing. Okay, and so now I do the third thing, and finally we get the table that we want. So apparently this is the third embedded table, and it says, okay, country, territory, UN region, IMF, you know, this and that, and then we've got, you know, country, territory, world, the United States, China, Japan, Germany, India, and that indeed reflects exactly what we want. Okay, so now that we found the table, we know it's the third table on the page. We'll go ahead and we will save that. Right, so I'm taking the code here, and I'm going to just precede that code, and I'm going to store it into an object called GDP. Okay. How do we feel about this? Is this feeling okay so far? Kind of. All right, let me, give me a second. Let me give you your first view quiz answer here. All right, well, it's loading up. Okay, well, so we've stored GDP, and we can kind of just take a preview of it. I can hit GDP here, and this is what it looks like. I can also click it in the environment, and we can see this is the contents of the table. And it looks a lot like what we see on Wikipedia. And so anytime you are doing web scraping, you know, always keep the table, the website open, and just do kind of a comparison checks and just kind of make sure everything is matching, you know, so far. Okay, and so far it does look good. There's a few quirks though. Okay, one thing is if you look at the data, it says there's 218 observations of 8 variables, and if you go on the Wikipedia page itself, there's only 216 countries listed. So where are these extra two things listed coming from? And what we see is that in our table, the first 2 rows are, the first row is basically the column headings, country, territory, UN region, estimate year, estimate year, estimate year, and then the second one is for the entire world. So that's, so we don't actually want that, okay? So we're gonna, what we have to do now is we have to kind of clean up the data. And so and this is going to be a common thing. Anytime you read stuff off of the internet, it always comes in as kind of like text, and you have to kind of let R know this text is actually numbers, and we want to be able to handle it with numbers. Okay, now let me give you your first VueQuiz answer for week 7 Wednesday. Okay, the first answer is the letter C. C as in cat. C as in cat is your first answer. Okay. So everything in here, and it actually shows you. We can see the column headings. Underneath it, it says CHR. So this says, it's treating everything as characters, right? So even though these look like numbers, the way R sees it, it's basically like a phone number. You're not going to be able to add numbers together. You can't take an average of phone numbers or zip codes or something like that. It's just treating these as characters. And so so we need to tell R, okay, we need to turn these into numbers. There's a few other things. There's little footnotes here, okay? So on the Wikipedia page, we can see, when it says like citation needed and stuff, these are little footnotes, and this, appears as text in our thing. And so that kind of throws the things off, okay? And then our column headings at the top, there's like 2 rows of column headings. We have IMF estimate and IMF year, World Bank estimate. So these are, how are we getting, different sources of information have, slightly different numbers for what the GDP is for a particular nation. And so anyway, what I have is we're going to try to clean some of this stuff up. Okay. So first, I'm going to clean up the column headings here. Okay. One thing to note is that all of these column headings, as they currently are listed, have these backticks, which is okay, but it's becomes difficult to work with. And so to avoid having to use backticks in the names, you want to make sure you don't use any spaces in your in the column names. So or special characters other than so I've replaced all of the spaces with underscores, and I've replaced instead of having duplicate column names. So we can get the current list of column names. There's 8 columns, and you can do names, GDP, and these are the current names. And again, it's just taking the top level and it's turning that into names. And so the IMF, International Monetary Fund, we got the estimate and the year on which the estimate is based, appears here. And so what I'm going to do is I'm going to just change the names of these columns into just preferred names. And this is a bit of a manual process. There is, we've seen the tool Janitor, which will automatically clean things up. And if we didn't have like the same column listed twice, maybe I would have used that. But here, I'm going to just kind of manually clean this up. So here, I'm just creating a vector of the column names that I want to use. So I'm going to say, the first one's going to be country, then we've got region, and then we've got the IMF estimate and the IMF year, the World Bank estimate, the World Bank year, and the UN estimate and the UN year. And I use the assignment, and I'm going to say replace all of the current names of GDP with the names I've provided here. So I'm going to go ahead and I'll run that line of code. Okay. And so now if I take a look at GDP, we see those column names appear. Okay. So far, this is looking okay. Again, we still can't use it because everything's still a character. I also want to delete the first 2 rows. I'm going to delete, just these words estimate and year, because those were column names. And then we'll also just get rid of world. I mean, I suppose I could leave them in there, but I'm going to just go ahead and delete that. If you wanted to keep that in there, you don't have to delete it. So there's several ways you could do it. One is we could use square bracket notation and specify the rows we want to keep. So I can do GDP square bracket, keep rows 3 through 218, and then keep and then put a comma there. You need the comma to distinguish between things that specify the rows and the columns, and we're going to do that. And so that will give me 216 rows, 8 columns. The first one is the United States. That's what we expect to see. Same thing, but this time instead of specifying the rows I want to keep, I'm going to put a minus sign and then put in the rows I want to get rid of. So I'm going to do, in parentheses, rows 1 and 2. Those are the rows I want to get rid of. I'm going to put a minus sign in front of it, and we'll get the exact same results. 216 rows, 8 columns, first row is the United States. Okay. The tidyverse has a very similar function, but instead of using the square brackets, you can use slice. And so here I can say slice and keep rows 3 through 218, or I can slice and get rid of rows 1 and 2. All right, so all of these things, they all result in the same thing. So I'm going to just update. So all of these things, because I've just, it's been putting the output out here, I've just been saying, take this thing and show me what it looks like. None of the objects are actually updated. So the GDP object in the environment still has 218 observations. And so to update that, I'm going to just assign the result of slicing out the first 2 rows back to GDP. Okay, and so now when you check the environment, we see we're back to 216 observations. Okay, or down to 216 observations. That's what we want. We are still not done, and I know this feels like a lot of steps, and I think it's because I'm just explaining every single step along the way. You'll see once you get kind of the hang of this, a lot of these other tables, you realize, okay, a lot of tables are similar, and we can just do kind of the same operations here. Okay, so we have to clean up the data. So one is we want to get rid of all of these footnotes that come in square brackets. All of these things have numbers. We want to get rid of the commas as well. Okay, we've seen some of these commands before. So they are the string-related commands. We've seen string detect, which allows us to detect if a certain word or pattern exists in the text. Here we're going to use string replace, and I put some examples of this in your homework when you're working with the dates as well, because I think there's a lot of footnotes in that table as well. So here, fortunately, all of the footnotes have kind of the same format. Square bracket, something inside the square brackets, and basically we just want to get rid of any time we see a square bracket, we just want to get rid of that stuff. All right, so I'm going to do a string replace. And here I have string replace all, but I could have just used string replace. And basically we're going to specify the column that we want to scan. So here I'm going to look at the column IMF year. And the pattern that we're going to replace is square brackets, wildcards inside, followed by square bracket. I have, we have these backslashes before the square brackets to indicate we are looking for a literal square bracket character and not, sometimes square brackets can be used to indicate, classes of characters. And so it's a little bit funny to kind of say this, but some of the characters you have to put backslashes in front of them. So that would be things like square brackets, parentheses, curly braces, if you want to find those literal characters, and then others you don't need to put backslashes in front. You can look up regular expression meta characters. The entire topic of regular expressions is a little bit beyond the scope of this course, and so at this point right now I just want to say if you need help with cleaning up some of your text, I'm happy to help you during office hours as well. you can always also use the internet and say, how do I write a regular expression to do this thing? But here we just want to look for things that start with a literal square bracket, end with a literal square bracket, and inside dot star is means everything, anything, including any character, including spaces. So this is just the wild. It's so it will kind of match everything there, right? And here we're going to say look for that thing, and then replace it with basically nothing. I just have quotes with nothing inside, empty characters, empty character there. So here I'm going to say replace all, and we're going to replace the current column IMF year, and so this goes inside mutate. We've learned mutate about to either create or replace columns here. So if I do GDP mutate, what we want to see is IMF year. We're going to lose these square brackets, okay? And again, right now I'm just kind of previewing what's going to happen. I'm not assigning this anywhere. So if I run it, what do we see? Indeed, it looks like, at least for this first row where China, where we had a square bracket, they removed it. So that's a good sign. Okay. And so I want to do the same to World Bank year and UN year. So I just copied and pasted the exact same code, and I just pasted it 3 times. Okay, so I said I want to do it for the column IMF year, do it for the column WB year, and column UN year. Okay. So I will go ahead and do that. And again, just kind of previewing what's going to happen. We chain these mutate commands, and it looks like it's working. Okay, so those square brackets associated with China have disappeared. If you here when you preview, the default is just to show you the first 10 rows, and if you want to take a closer look, you can always pipe this into capital V view, and this will give you a preview of the entire table, and it's going to kind of pop up here, and you can kind of go through all 216 rows, and what we want to see is not a single square bracket in here. And as I kind of scroll through this, it looks like it's worked. Okay, it looks like it's worked. I don't see any square brackets in there, so so that's a good sign. Okay, so this is obviously something you'd only want to do if you have only a few hundred rows. If you've got like hundreds of thousands of rows, you don't want to have to view everything in there. Okay. All right. What do you think we should write if we want to get rid of commas? If we want to get rid of all of the commas, what can we do? So, okay, we would write string replace, right? Or string replace all. And then I'm going to say replace anytime you see a comma, okay? And a comma, we don't have to put backslashes in front. We can just leave it as a comma, okay? So we're going to put the comma there. We're going to replace the comma with nothing, okay? And this is going to apply to the IMF estimate, World Bank estimate, and UN estimate. Okay, so here again, still just kind of chaining everything, and then finally, I'm going to assign it to GDP here. I guess it's always kind of wise not to do the assignment and just do a preview and make sure it looks the way you want. And then once it looks the way you want, then you can assign it. Okay, because right now, because eventually the ultimate goal is we want to turn these into numbers that we can like do calculations with, where we can calculate the mean and things like that. But if you try to convert text like as numeric, and if you do put in 100, that's fine. But if you have like say 1, 1,000, okay, R hates seeing these commas in there. So if you have these commas in there, it breaks. So we have to get rid of the commas. Okay. So again, so I'm going to just kind of preview what we want to make sure we get rid of these commas here. So I just did string replace, and again, IMF estimate, WB estimate, UN estimate, and we're going to replace all of the commas with nothing. We preview that, and all of the commas are gone. So this is before with the commas. Now we have no commas, and that looks good. Okay. Again, we can also pipe that into view to kind of make sure the results look the way we want. But I'm going to go ahead and say this looks good, and we're going to assign it to GDP here. Okay, and so we can just kind of preview GDP. Everything looks okay. There's no commas. We do have some dashes. All right, and anytime you see something that looks a little bit funny, you kind of just want to verify that your source data matches that. And indeed, Taiwan does not have a GDP from the World Bank. You know, there's political situations there, and then, you know, like, do we recognize Taiwan as a separate thing or not? You know, and places also, you know, places like North Korea, you know, we don't have GDP information there as well. So, you know, when we preview our data, okay. So where is the North Korea? North Korea is 138. So if I go down to 138, you know, we expect to see, you know, dashes there. Okay, and indeed that's what we have. Okay, so everything kind of matches what we're seeing on the web page, also in R. And again, that's kind of an important thing. We want to just make sure you know, we're not inadvertently altering the data itself. Okay, and so what I want to do now is I want to convert these things, which are currently stored as characters, and turn them into numbers, right? And so the function we can do is as numeric. There's, you know, specific things where you can specify, I want to turn this into integers, and I want to turn this into floating point numbers. But as numeric, we'll just kind of use the default, which is floating point numbers, allowing for decimals. But and there's a few ways I could do this. One is I could go through every column, and I can do mutate. IMF estimate is as numeric. IMF estimate, IMF year is as numeric. IMF year. WB estimate is as numeric. WB estimate, and I could list this off. And this, I think we could read and understand this. And if I do that, it looks like nothing has changed, but this information right here has changed from up here. It says character, CHR, 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 okay? And now I have DBL, 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 double. Double means it's a number, okay? Type double is double precision floating point. That's just the way R stores its numbers, okay? And so that's a good sign. We want to see type double here. For kind of efficiency in our writing, because we're using the same function for all of these columns, there is kind of a shortcut function called across. And so rather than having to list off every single column, I can say mutate across, and here I'm going to say from IMF estimate to UN year for all of these things, apply this function as numeric, right? And so that's going to give me the exact same thing. And that's what we have. It says, you know, we get these warnings, okay? It says there were some warnings, and the warnings were NAs introduced by coercion. And that basically means there was some text in here that it couldn't figure out how to turn into a number. You know, so for example, like if your column had the word house in it, it would not know how to turn this into a number, right? And in our case, it saw those dashes, and it said, I don't know how to turn these dashes into numbers, okay? So anyway, I'm going to go ahead and update GDP. I'm going to do GDP mutate. Again, everything so far here has just been previews, and in order to actually update the GDP, you've got to store it. So I'm going to do that, and then we'll go ahead and take a look and just kind of see if everything looks right. And it looks okay. And what we see here is Taiwan, where we had dashes, now we have NAs, indicating that these values are missing. And that's That's perfectly fine. That's what we expect to see. Okay. So that's great. That's great. Let me, I've only given you one answer, right? Okay, let me give you your second view quiz answer. Second view quiz answer is B. B as in bear. B as in bear. Okay, and then so now that we have this table, we can, you can work with it, right? So you can do GDP, and you can do, select, or actually not even select, we can just do filter region equals Asia, all right? And so we could see all of the kind of the nations in Asia. We could say, summarize, and we can do something like the mean, and we're going to ask for mean of the IMF estimate. Okay, we get an NA because we have some missing values, so we'll do NA.RM equals true. All right, and so that's the mean of these things. I don't know if that's a particularly useful thing to calculate because we're averaging all of these nations' GDPs, and obviously some of these nations have way more people than others, and so how great is that? I don't know, but the idea is we got the table from Wikipedia, and now it's in a form that we can kind of interact with, right? And if you want to do a join between this table and the other table that you're working with, it's in a format that you can work with. My hope is you'll have this R script as kind of a starting point, and you can kind of modify and use it to fit your needs. Some of your groups are working with NBA data, and perhaps you wanted to download a little bit of information on some NBA players, right? So, Wikipedia, good old Wikipedia, we've got, here's a page with information on NBA players. And so the NBA celebrated its 75th anniversary, was it last year? A couple of years ago, just last year in the 2022 season. And they picked the 75th anniversary team, which I think consists of 75 I forget how many exactly how many players, but basically all of these sports writers kind of voted, and they said these are the players that we think should be on the anniversary team, and so they have these players listed. And so let's say we want to download and get this information into R, and so we'll follow the same kind of process here. And here I'm going to just replace my URL with the URL of the page we want. And so here I'm going to just kind of go through it a lot faster this time. And hopefully you'll see, once you kind of have a good script, it's relatively quick and easy to modify, right? So we're going to read that in, and then initially we're going to just look at all of the tables on the page, right? And so there are 9 different tables on this page. Let's see. 9 different tables on this page, and we want to see, all right, which table, which one is the one that we want, okay? And so the table we want, after a little bit of trial and error, is the second table on the page, okay? And that one actually seems like very reasonable. This is the first table on the page, and this is the second table on the page. There's no other tables kind of hidden away here. So this time it's the second table on the page, and we're going to say, convert that into a table, and we see, okay, we've got the name of the players, the teams they played on, their position, their points, rebounds, assists, all of these kinds of stats. And so we're going to, use that as a starting point. I'm going to store this as NBA 75, right? And again, the names of the columns, some of them have spaces in it, which makes it a little bit harder to work with. So I'm going to go through, and we're going to just replace these column names with names of my choice. And again, this part is a manual thing, and I'm going to say, all right, Let's do names, teams, position, points, rebounds, assists, championships won. I'm just going to call it champs. MVP won. So these are awards that players could win. And so I'll just do MVP. Finals MVP is another award that players can win. There's All-Star nominations, All-NBA, Hall of Fame, if they're inducted into the Hall of Fame, and then references. And so I'm going to just kind of rename all of the columns there, and we'll just kind of take a look. And again, this is what we have. Some of these things, it actually, when it contains only numbers, RVS was able to recognize that these are just integers, which is great. But other things, when you have the commas in these numeric entries, R doesn't like that. And so we're going to go through and we're going to say, all right, take the points, the rebounds, the assists, get rid of the commas, and make them numeric. And you can actually, within mutate, you can chain these commands together. So I'm going to say points is we're going to replace within points any commas with, just remove them, basically replace commas with nothing, and then convert it to numeric after you do that string replacement. So I've got points, rebounds, assists, and we'll just kind of preview and just kind of make sure everything looks good here. And so this is what we have. We got points, rebounds, assists, and doubles, and they're all type double, which is what we want to see. Okay. Other things maybe we want to do is perhaps we want to take the number of championships they won and just get the number there. Okay. And right now the way it is if Kareem Abdul-Jabbar won 6 championships, and it has 6, and it also lists off all of the years in which they won a championship. So 1971, 1980, 1982, with the Showtime Lakers, right? But maybe I just want that number 6, okay? Or maybe you want to keep the championship years, I don't know. But here I'm just going to say I just want to keep the number 6, and so what I'm going to do is I'm going to say, find anything inside parentheses. So I've got / parentheses, content dot star to say anything, and then with a closing parentheses. So it's going to kind of replace everything within parentheses and replace that with nothing. And then also we're going to take the word none, right, where it says this player doesn't have any championship rings. Okay, so we're going to replace none with a 0. Okay, so we're going to take the none and replace it with a 0, and then we're going to do as numeric. Okay, so here, again, you can kind of pipe all of these things into the same operations, or you can just say, take champs, and then and it will, as it's working through this, it will go sequentially through them. So if you say champs and then take the champs and then take champs and do as numeric champs, you can do that within one single mutate command, and it will understand, kind of take the result of this this variable you just kind of modified and do it. So if I do that, what we'll see is indeed this championship column has the numbers we want. Doesn't have the years in which they won the championships, and we replace the nones with 0s. Okay, and so so that's just kind of an example, and hopefully this bit of code for the NBA table maybe is a little bit easier to follow along, just because it's all kind of condensed together. And so this is, in my opinion, a very handy and useful tool for getting data out of different web pages. It doesn't have to be Wikipedia. One of our teams was looking at baseball player salaries, and what am I typing? Salary, right? And so this was on this website, SportTrack, and this, unfortunately, the original kind of page with all of these players listed actually uses like dynamic loading, and so when we tried to pull the page, it only pulled the first 100, because apparently after the first 100 it like dynamically loads that content. So so what we ended up doing was we said, okay, well, let's just pick one of these teams, and we'll read this in, okay? And so when I did that, we got this data, and we looked at the tables, and there was some trickiness to work with, just because there was a lot of kind of weird characters in the text for the names, and a few different things were going on. But ultimately, we were able to get the data out of the page using read HTML and HTML tables. So I would say we had success, but a lot of these things with cleaning up the text can be a bit tricky. So again, don't hesitate to ask for help during office hours. And then there's also plenty of resources online where you can kind of teach yourself or just learn some of these things out there. Okay, but hopefully this script is a good starting point if you're in the situation where you want to get some data from some kind of table on a web page. Okay, let me go ahead and give you your last view quiz answer today. Last view quiz answer is the letter A. A as in apple. A as in apple is our last view quiz answer. All right. I don't know, any questions on getting stuff here? Okay, well, we'll call it a day here. I hope your projects are going well. If you have any concerns, or if you want to just bounce some ideas and say, hey, are we in the right direction? Or, here's an idea we want to explore and we're not quite sure how to do it. Again, come by, and I'm happy to try to help you guys out. All right, have a great rest of your day. We'll see you on Friday.